Okay, let's get started. Good. I want to start at the end today, and then I go back to the beginning after an interlude. So when you create your AWS account and you log in, you've done that, right? You should do it. You get a page like this, and if we then there's S3, which we'll use. This is where all your data goes, input and output. And you get a nice little web page that allows you to create buckets, and buckets holds files. And there's a little create bucket, right? And we can go inside of each one of these buckets, and we can see the contents. And I got various jar files there. And there's an upload button that allows you to upload a file from your machine here. There are numerous different clients that will talk to S3 and allow you to upload or download files. So you might be able to find a better solution. But there's this solution. So that's S3. The next thing we're going to be interested is, come on, Amazon, what they call EMR, Elastic Map Reduce. And here are the various clusters I run recently. There's a Create Cluster button. You click on that. And then we can give it a name. Launch mode, usually you want the cluster. This is the log directory they gave my account, so it goes directly to my S3 account. We're interested in running Spark. We can determine what types of machines we want. Older generations are cheaper to run, and the smaller ones are cheaper, so I'll just pick M1 medium, and only 3 instances, 1 for master and 2 for slaves. I've created a EC2 key pair, which we'll talk about this later. And then there is a create cluster button, and I click on that. And I've just spun up 3 machines on AWS Cloud. Sort of anticlimactic, I know. And we'll leave like this for a while. It can take, depending on how busy they are, 5 to 15 minutes for the cluster to actually appear. Actually, we can add a step. So let's do that. And I want to do a Spark application. I can leave the name as it is, deploy cluster. In the Spark submit option, so I need to tell it at least the class that we want to run, in which case a simple app. And now I need to No, I need to give it the location of the jar file I want to run. I've packaged for my application, and it's s3:/ and I've created a bucket called rw-hadoop-jars, and then I just called it simple app jar to make sure I spelled everything correctly. And then I need some input. And my program expects the first argument to be the directory it's going to write the output to. And again, using their file system S3, and I've got rw-out put-data. And then I'll just say class demo, and I need to, okay. Now I've added that, and so when the cluster is ready, it's going to run that job. There are a couple things I'll point out for those who like to do such things. SSH. If I click on this, it gives me the SSH command I can use to log on to the master. And so I can just copy that and run it in a terminal and log on to the master. It's, well, we can see if it's ready yet. I have no idea. We can try that. But then we need to select a source. Maybe. So now I can copy this command, and I go to my terminal window, type it in, and it's always going to complain. And now I've logged on to the master node. And it's a Linux machine, so you can do the various Linux things and look at it. And your home directory is empty, as you'd expect. Don't need this anymore. And as you can see, there's one other thing I want to point out. For those of you who don't like to go through the web and like command line interfaces, there is this AWS CL export, and that gives you the command to actually spin up a cluster of this particular description from the command line on your machine. after you've created the proper security features, right? And so you can you actually can spin up a cluster, submit jobs from the command line on your local computer rather than going through the web. Okay, so our goal is to understand how to write the programs that run all this. Before we do this, and as you can see, we're still waiting for the cluster to actually be configured, even though I could log on to it. So like I said, it's only been 7 minutes. It's probably a busy time of the day, so it could be another 5-10 minutes before it actually is ready to run. But like I said, before we do that, there are two things I want to talk about. So as you all know, there was another one of these internal shootings over the weekend. And actually, 21 years ago, there was actually an incident on campus where a graduate student was rather upset. Apparently, he thought that his committee was about to fail him when they're about to pass him. And rather than wait to find out the answer, he just pulled out a gun and shot all the faculty and killed them on this committee. Given the number of instances happening, the university is now providing faculty with sort of training. What do you do? What happens? What should we do if all of a sudden we find out that there's a shooter on campus? What should we do, right? And they said, well, the first thing is if there's someone in the building or might be in the building with a gun shooting people, you probably don't want to be running around in the hallway because guy with gun and you running, bad situation, right? So if you don't know who the shooter is, what you want to do is you want to secure the door so they can't get in. Why? Well, because they have a limited number of time and they're trying to kill people, right? And if they walk up the door and they can't get in, are you going to spend 10 minutes trying to get in the door, or are they going to go to the next door and find someone else to shoot? So in this room, right, the door actually locked, which is nice. But it also has, you notice it has those two bars going up. If it doesn't lock, what you could do is we could take a belt or some rope and, right, tie it down so they can't get in. It'd be sort of nice to cover up the glass if we could so they couldn't look in. So they could come to the door, it doesn't open up, right? Then move on. Might want to turn off the lights and not be in direct view of it, right? And then wait until we find out that it's okay, right, to leave. They also suggest that people don't get on social media and say, I'm in this room and there's a bunch of us and we're hiding from the killer. Right. In part because, yeah, that's the issue, right? They also suggest that one person then contact the local police, right? And let them know that we're in this room, but, and then just basically wait until we get the clear signal to do anything else. So that was their basic recommendations: is you just lock down until things are okay. Second thing, it's also time to talk about projects. Generally, I let people work in teams of two. I don't like to have big teams. Once you get more than two people, it's my experience that one person won't do any work or do minimal work, right? And then what happens is, since your grade depends upon it, the other people, and sometimes that's planned, right? So sometimes what happens is students say, okay, well, there'll be a team on that course and be a team on that course, and then you do the work on that course and I'll do the work on that course, right? Another strategy. Um, but so teams of two. Um, the reason, in general, I don't like to have projects in classes because of more work, and then when something goes wrong, what do you do? The reason I do projects now, in the past, I've gone on sabbatical to the University of Illinois at Champaign-Urbana, and I noticed that the students there tend to do a lot of projects. Um, let's see, the first web browser was a student project. YouTube, student project, right? A lot of little companies come out of there, and you're like, why is that? Well, part of it's because the town is in the middle of a cornfield, and it's winter, and what do? Um, the other reason is after their first semester, as a freshman, every course, you walk in any course, and they say, here's what we're going to cover this course. Here's the book. Here's all papers, all exams, assignments. Oh, and you're doing a project. And it's not here's your project. It's no, you're going to come up with a project for this course, right? And it's like I said, every course after the first course is freshman. At the graduate level, same thing happens. Is every graduate level course, it's like you're going to do a project, and it's right at the graduate level. You're going to do a project, and then you're going to write a paper about it, right? And if it's a good enough paper, then you're going to put the instructor's name on the paper too, and you're going to submit it to a journal. Um, and one of the things that happens is if every semester you have to think of a project, what do I do for every course? You start to get good at thinking of projects to do, right? Um, so much so that their student ACM chapter um, is huge. The first meeting every year, there's like 80 people show up, and they break up into small little groups, in different subgroups, and then their goal is to come up with a project that they will then do for the year. And then there's an annual engineering day in the middle of spring semester where when you walk down the computer science building, there's just tables, all down the hall, students showing their projects, right? So, why do things like YouTube and web browsers come from there? Well, because they're being trained to think of what should I do, right, for a project. So what types of projects can we do in this course? Well, one sort of project would be, particularly if you've taken the machine learning or data mining course, right? Oh, find a data set and then, pick an algorithm, decision trees, clustering, machine learning, right? And then run it and then get the model and then show the prediction. And you can write a little couple of paragraphs saying, okay, here's my data set. Here's what I learned, right? We can also do comparisons of models. What was, is this particular machine learning algorithm better than this one? Or maybe we'll do clustering and we'll then do a comparison between various parameters, hyperparameters, see how they work. Well, later we'll be talking about streaming. So you might want to then look at streaming. Maybe, one common thing is to tap into the Twitter, public feed, and then do some analysis looking for various terms. And so you set up this pipeline where you're ingesting a continuous stream of data. Maybe trying, a number of things people do is like, okay, let's see if we can detect, oh, there was a shooting. Can we look at that and see, how fast things spread, or what sort of analysis we can do there. Right, so we can start looking at streaming type of data, although finding the source becomes hard because you want something that generates the data. When I start looking at the slides, I'll talk about SMAC. And so there's some people in the room that like to play with hardware. And so they could set up your own cluster, right? When you're doing AWS, we're using AWS's cluster management. There's various ones we can use. Yarn's a common one. Mesos is becoming popular. So set up a cluster where you install Spark, Mesos, and a few other tools, get it all working, and do small examples, right? It becomes a different type of project. But I'm also not one to say, here's your project. Because as soon as I do that, it becomes just like an assignment, right? And I find several things happen when I say, you're going to do a project and you're going to come up with an idea. Versus students are used to doing that, so like, what do I do, right? The second thing happens is once they find the idea, they usually work harder on it than they would an assignment. Because it's their idea, not. Questions? No. We didn't do projects last year. But it becomes easy to grade, yes. What's that? Double or nothing becomes dangerous. Except for the nothing part, right? Any other questions? How many more assignments are we going to have? I don't know. What's that? Yeah, the next assignment is going to be basically take part of your assignment 4 and run it on Spark, on AWS, just to get that workflow down. And for the rest of the semester, there's still a few machine learning algorithms we can look at, clustering. Also want to look at streaming and looking at Kafka, which is another streaming system. Any other questions? How will it be valued? I forget what I said on the syllabus, how much it would count. Other questions? End of semester, right. Well, to be precise, the day that your final would have been scheduled for. What's that? What's that? And notice, well, I can refresh. Oh, so it's done, right? Because now it says waiting, which means it's done. We can now go to steps. Oh, it still says they're pending. Let me refresh the page. And so they're completed. And so there's, for each job, there's various things we can do. We can view logs. And oh, there's something I need to warn you about. That, if you're going through the web interface and you want to look at the log files, you can't block pop-up windows. And so there's standard error log, which has a bunch of stuff which is not very interesting. And there's a controller, which again gives you environment but not much else. And view jobs, it doesn't tell us anything. And that's about it, right? And if we now go back to services, well, let me terminate this before I forget. Yes, I do want to terminate this. And you go to S3. And that output. And there's no class demo. And file is separated into 15 parts. And the program didn't do anything interesting. It just downloads it. Yeah, we'll talk about this later, but we can look at its contents. Bring download, look at it. Okay. And what else did I want to talk about? Yes, we go back to there are several things. One is I can select a previous cluster, and then clone it, so I can then restart that cluster up and run the same jobs. Or I can just clone it and say don't repeat the steps. The other thing you note is all of the clusters I ran, I just had 3 machines, a master and 2 slaves. And the normalized instance hours, the first 2 I terminated before they actually got running, and so then those are hours. Those 2 clusters I used a large instead of a medium, and each I only ran for part of an hour, but when they normalize instance hours, they always round up to the hour. So I had 3 machines for an hour, right? So it should be 3 hours. No, well, because each machine was worth, and it had multiple CPUs on it, right? Here using the medium size, again, 3 machines, 1 hour, but each, right, count for 2 because so when you're playing around, you may want to you're not doing a lot of computation, pick the smallest one you can, right? They also have their billing page is not particularly useful. It says I haven't used anything this month. I don't know if it's updated. However, the price is pretty small. I mean, if you choose a small machine, I think it's 2 cents an hour. And the new billing policy, which is started earlier, I think late this summer, was in the past they charge you per hour, right? And they always round it up, right? So if you use it for part of an hour, you get charged an hour. They changed that to per second. Although they do say that the minimum amount of time they'll charge you is for a minute. Yeah.
So as far as like big files you upload, are they in paper space?
Yes, there's a charge for S3. So there's a charge to import them, and there's a charge for storing them.
If you want to run a lot of data, would you put it all in the cloud?
If you have lots of data, you put it in the cloud first, then you run it, right? And depending on how big your data is, if you get a lot of data, instead of doing it over the network, you have them send you a box, and you put it in the box. And if that box isn't big enough, you could help drive a truck up to your place and plug into your network, and then and later we'll see some of the prices they charge. I mean, it's the cost on S3 for storage is low enough. People use it for backup, right? Any other questions? Okay, then let's get started. So I recently came across, why is that one? That's 5. No, wait. Where is, I came across the term smack recently. Apparently it's popular in the Bay Area among engineers. The S stands for, sometimes it stands for Scala, and sometimes it stands for Spark, or sometimes it's for both. I guess having SS doesn't look good. Mesos stands for, or M says Mesos, a distributed system kernel. People use that to for cluster management and distributing data. ACA is a actor model for doing distributed processing. And Cassandra is just a fast, scalable, highly scalable NoSQL database. And then Kafka is a streaming system. We'll look at that later. We should know the terms, right? And if you like fiddling with software, you can, and you've got several machines laying around, you can try running all these on your machines. Make a project out of the course. So if you want to run Spark on AWS on a cluster, we need to package our program into a jar file so we can upload it, right? So we're going to look at how to package it up. We're going to look at, we can create a cluster on a local cluster of one machine to run it in that mode and make sure that works. And then we'll look at logging and how to deal with files. So up to now, we've been using notebooks, right? Doesn't work. To run it, we need to create a program, and there has to be a main, and that main is going to be an object, right? Now, last year when I taught the course, a number of students, when they created a jar file, they added everything in the jar file, right? They basically created a jar file that contained all of Spark and all the jar files that come with Spark. And then they uploaded that to AWS and they ran it. The program I just ran, I think the jar file was 2K. If I had incorporated all the jar files, then over 200 megabytes. So you don't want to do that, right? There's one advantage of that is if you include all of Spark, then that jar file becomes a standalone runnable program. But if you're just going to run Spark on one processor, you don't need to go to all this work to do that, right? You can just use your notebook. You can to package this jar file, it has to be a jar file with a manifest, and that can be done by hand if you want. The jar command to come to Java, you give it the jar and you give it the manifest file, and you say put this in it. And but the easiest way is to use SBT, which stands for the Simple Build Tool. And the reason you really don't want to deal with that 200 megabyte jar file overhead is that you have to submit the jar file to S3, and then it has to be loaded onto the master, and the master then has to send that jar file to all the workers, right? It's going to slow the program down a bit to have to push that mount around, right? Right. So Spark has, when we look at the Spark install directory, right, there's a long list of jar files that come with it. When you run Spark on a cluster, Spark provides all those dependencies, right? So you don't need them. If you create a jar file that does not contain them, it's much smaller, but that jar file is no longer runnable by itself, right? You have to run it in the context of Spark. You have to say, Spark, here's a jar file, run it. And you have to tell it, here's a jar file, here is the class you're going to run first. So it's a trade-off. Do you want a big, huge jar file which you can double-click or run by itself, or do you want a small one, but then you have to then submit it to Spark? If you're running AWS, since you already submitted to Spark, there's no sense in including all of Spark itself. So here is sort of a hello world program. It's about the smallest program we can write that does something, right, that we can run. And so it's, first of all, remember what object means in Scala, right? There's classes. The classes don't have static parts, so the object is, right? And then you need to have a main. So that becomes the main part that is run. And then I need my Spark context, since I'm just doing RDDs, to keep it simple. And to do that, I need a Spark configuration. And all I do is give it a name. And then I take a list and parallelize it, and then I write it to a file, right? Notice there are a number of things I don't do. I'm not using show, right? Take and show me this or collect this. When you run this program on your machine, right, you can print output and you'll see it. You can log things, you can see it. You can do show. All that goes to the log file. When you run an AWS, it does not work. You will not see any print statements. You will not see any output from show or collect. All those things are hidden. So when you run it on AWS, the only thing you get is writing to files, which does make it interesting, because when you make a mistake and the only output you get is writing to file, testing it under Jupyter Notebooks does not work. Why? Well, because it has to be like this, right? We do IntelliJ, right? So we want to use, so the standard thing with Scala and Spark is to use, well, the standard for Scala is to use the simple build tool, right? And to do that, you need a build.sbt file. And here is the SBT file for Spark. The first thing you know about SDB is that it's supposed to be a simple build tool, and the language it uses is Scala. So you actually write Scala code in SBT that SBT uses it does several things. It'll download your dependencies that you need, and it actually will build the jar file for you. It also compile the program, right? Standard sort of thing the build tool does. So here it's just give it a name, we get a version, what version of Scala do you want to use, and then library dependencies. We could do all kinds of libraries, but this one is for Spark, and it will download it for you. The syntax is a little weird at first. The 1% means just concatenate these things. And I think there's a period in between them. The double percent says, oh, put the version of Spark of Scala there. So you're basically going to give me the Spark for Scala version 2.11.11. And so if you want to use an older version, you can do that, right? And also what happens is, if you want to run this program a year from now, and there's now a Spark 2.3 and 2.4 and 3.1, right? If you run this, you're going to get the Spark for that runs Scala 2.11.11. That's what build tools are for, right? To manage your dependencies so you don't have to keep on updating things or not updating things and worry about that. Now, one word of warning. I spent Friday afternoon and most of Friday night having fun with SBT. It wouldn't work. And the solution was SBT builds a local repository. Somehow it got corrupted. The solution was delete the repository and run it again, and it works fine. The problem was the error message I was getting is it was pointing to my Maven repository and saying there's a problem there. I'm going, why are you pointing to the Maven repository when I'm not using Maven? I have no idea why, but it took me hours to figure that out. SBT expects things to be in has a certain file structure, which is what Java uses. So this particular application, I put it in a directory called simple app. And then at the top level, then there's this build SEP, and there's a source directory for your source. And then there's main, inside the main is Scala. And then since I'm not using a package name, then comes my app, my source code. If I was using a package name, the standard thing that you do in Java is that you then, each part of your package name becomes a subdirectory until you get down to your source. And then just using SBT, I didn't start using IntelliJ. You can go to that directory, and after you've installed SBT, you just type SBT package. And that will then compile your code. And if you get any error message, it'll tell you the error messages. And actually, the first time you run it, it actually downloads all the dependencies you need that you list. And then it will produce a jar file that contains a compiled version of that code. Simple, right? And it produces a number of different directories. the project directory basically contains information about the project in one file, and it tells it the version of SBT to use. The target contains a number of things. SBT uses incremental compilation. So when you make changes to your source code and then compile it again or package it again, it doesn't have to recompile everything. It can link only to the differences. And then it creates the jar file and it gives it the name of your project and then the version of Scala I'm using and then the version of the project. I noticed that it's only 2 kilobytes. It's not 200 megabytes. So it just contains our project. If we're using dependencies not included in the SBT build file, then we have to put them in our project manually. And there's a way of doing that, but we'll cross that bridge when we come to it. And then locally, I have Spark installed on my machine. And I put my Spark home /bin and Spark home /sbin on my path, so I don't have to type in the path to those commands. I just type the commands in. I've also set the Spark home environment variables. I'm not sure where that's used, but that one of the things when you install Spark it says you should do. And then there's a command called Spark submit. And when you call Spark submit, without telling it where the cluster is, it will just instantiate a local version of Spark and run it. And so I can just say Spark submit and then give it the path to the jar file. And then you get this, pages and pages of log files. And it runs your program. And when you print the standard out, when you do print line, when you do collect or show, it's all embedded inside that. Yes, we'll show that in a minute. Yeah, you can, because otherwise you get 5 pages of stuff and you then scroll up and down to find out things. And just turn it off, right? Yeah. Now we can also start up a version of Spark running, and so there's again an sbin. There's a start master.sh, and it'll start up a master node on your machine. And then there's Spark does a number of things. One of them, it creates, has a little web server built in to give you information about the master. And if you go there, it will give you the URL that Spark is running on. And that's useful for a couple things. One is if you want to start a worker, the worker needs to know where the master is so it can talk to it. And also, you can use Spark submit to submit to clusters on other machines. And then you need to know the URL for that master to put in the Spark commit command. And so then I can start up a slave. Now I've got a master and slave running on my machine. And when I go back to that page, it shows me, oh, I've got one worker. It only allows you to run one worker on the same machine. For most things, that's enough. If you have some complicated thing, might have concurrency or possible deadlock or live lock going on. It's not going to test that out very well, but that shouldn't be a problem here. And then the Spark submit, there is a second number of things you can set. One is where the master is, and you give it the URL for the master, and then you give it the path to jar file. It then gives that jar file to the master, and the master then sends it to the worker, and the job gets run. And then when you go back to the web page for the master, it shows you the jobs you've run. You can look at the jobs. You can look at their log files. Right. So it shows the completed application. And then you can look at the application, and then there's the standard error and standard out. So you can look at the log file. There's also a start all and stop all command. So when you do start all, it starts up a master on a slave. And stop all, this kills them all. And the full Spark submit command, there's -- class. When you run Spark locally, like I just showed you, you don't have to specify the main class to start with. Spark actually will look into the manifest file and see what the main class is. When you do this in AWS, you have to provide the main class with a -- class, right? When I ran my job, right, I created that task, I did say -- class. If you don't do that, that task will fail. And basically all you get is task failed. Then there's master where the URL is. Deploy mode, there's basically two ones, one on cluster, or you can, which basically says I want to, all the work is being done on the slaves. The master doesn't do anything. You can also have it run as a client on the master. The default on AWS is to run it as cluster. And then there's configurations. We do the various configurations. And there's a bunch of other stuff. Those are the main ones. And then we can do, here's a jar file we want to give. And then everything else after that are command line arguments read by the program. So typically what happens in AWS, you want to then, those command line arguments are, here's the input files you're going to use, and here's where I want you to put the output. Another word of warning on AWS, it will not overwrite a file. Right, so if you run the same job twice and say go to the same output file, the second time it will fail because it will not overwrite it. I suspect some of you will make that mistake. I've done it a number of times, particularly when you're trying things out, right? Okay, let me try this, try it again, and it will also fail on your machine when you run it this way, right? Yeah, that URL gives you the list of all the properties you can set, and it's a big long list, what they all mean. The name is what you'll see listed on the web page. The URLs you can use for the master. There's a bunch of locals. Local itself means just one worker. You can specify how many workers. The star means use one worker per core. And you can also specify how many failures. So if something fails, or how many times you should retry before it gives up. And then it also supports talking to a Spark cluster. But when we run Spark, we can use several different scheduling processes. One is Mesos, right? And the other one is Yarn, depending upon how the cluster is set up. AWS, we don't have to worry about that. Yeah. So what type of control does like Mesos and Yarn give you? They give you the ability to, how do you want to schedule jobs, right? If the cluster is idle and you only have one job, you don't care. But if you've got lots of people running jobs on, how do we decide which job to run first? Do we want to run a job until it's done? Do you want to multitask between jobs? Do we want to partition a cluster up into smaller pieces, and then people can then submit to which piece of the cluster they want? Can we give some people priority, some jobs priority to other jobs, so when they submit it, right? It also then, deals with concurrency and redundancy. AWS takes care of all that, right? Yeah, I mean, basically what I showed you in the beginning of class, I mean, you just spin up the cluster and then you can submit the job, um, and all that's taken care of for you. So the question is, when something fails, can we see the stack trace? I have not been able to find um, a way to see the output or when you write logs in your program at all. Don't know. I haven't I haven't tried that. But other questions? Right. So I mean, various. Yep. Yep. The snack was just. I came across this reference and it seemed to be very popular up there. So it's always nice to know the popular terms, right? particularly when you go interviewing, you don't want to say, huh? What I found, so we can spin up a standalone Spark session on your machine and use that to run against your program. I find that it's simpler just not to do that and spin it up each time. Why? Well, because my inclination is I'll just spin it up and let it run for the next couple of days so I run experiments. But you'd walk away for a couple of hours and come back and then something went wrong and I had to restart it. And it's like, no, I have to restart it? Why? If I'm going to restart it every while, why don't I just start it every time? I really don't need to see the history of the job I run because I'm still experimenting, I'm playing, I'm trying to make things work. So usually I found myself just using the first version rather than connecting to an existing running version. I suspect most of you are used to this. When you have properties that your program is going to use, usually you can set them in 3 different places: one in your program, one in the command line, and then the configuration file, right? And there's a precedence. And that is, if you set a property in your program, that takes precedence over any property set in the command line or in a configuration file. Any property set in the command line is going to be supersede any property in the configuration file, right? So there's several things you probably don't want to set in your program. One is when I go online and look at books, I often see them set the master in the program. Now to go to IDEA, why? Because when you run this on AWS, it's going to like, huh? Wait, where is that? Another one is you probably don't want to hard code name the output files or input files in your program. Why? Well, because presumably when you run these programs, you're gonna run it on a number of times, and so you may want the output file to be different, and you may have multiple input files you want to try it on, right? So hard coding it is a bad idea, right? So typically you'll want to do those things on the command line or a configuration file. So yeah, bad idea to hard code input output file names. When you create a project in IntelliJ, when you select the scale of project, one of the templates is SBT. And so when you do that, you get SBT right in a build. It creates a build.svg file which you can edit. And when you add source files, it puts them in the right place. And at the bottom, there's a tab that says SBT, and you can start it up, and it starts up an interactive session with SBT, and you can type in SBT commands. Right, and so if you want to do Spark and IntelliJ, you can use SBT template, and then just edit the build.svg file, and basically you need to make sure that you put the Scala version and then this line.
How do we include stuff?
No, this does not include all of Spark. SBT is smart enough because you say these are library dependencies. It does not include library dependencies in your jar file.
Are we scale out to 11.8?
It shouldn't matter. SBT has a number of commands. Clean and clean the project you're involved, right? Update all dependencies. You can compile a program. Package will compile a program and generate the jar file. And then test to run your tests. There's also a run command. That's not useful here because it will run your jar file, and your jar file can't run by itself because it has to run in the Spark environment. Any questions? So it's time. Apparently some of you have not created your AWS account yet. You need to create it. And then, what's that? Yeah, I mean, you log in and then once you've got your account, you really want to then go and get your $100 credit, which should take care of, unless you did something really stupid, it should take care of all the costs for this course. I mean, of course, if you create a cluster with 20 machines that run overnight, then on Thursday we will start looking at debugging. And we're done for the day.